New study finds that when everyday plastic products are exposed to hot water, they release trillions of nanoparticles per liter into the water, which could possibly get inside of cells and disrupt their function. So let's click on the article. So NIST study shows everyday plastic products release trillions of microscopic particles into water. NIST researchers analyzed single-use beverage cups, such as coffee cups, which can release trillions of nanoparticles or tiny plastic particles from the inner lining of the cup when the water is heated. Plastic surrounds us, whether it's the grocery bags we use at the supermarket or household items such as shampoo and detergent bottles. Plastics don't exist only as large objects, but also as microscopic particles that are released from larger products. These microscopic plastics can end up in our environment, and they can be ingested into our bodies. Now researchers at the National Institute of Standards and Technology, NIST, National Institute of Standards and Technology, have analyzed a couple of widely used consumer products to better understand these microscopic plastics. They found that when the plastic products are exposed to hot water, they release trillions of nanoparticles per liter into the water. The NIST researchers published their findings in the scientific journal Environmental Science and Technology. The main takeaway here is that there are plastic particles wherever we look. There are a lot of them, trillions per liter. We don't know if those have bad health effects on people or animals. We just have a high confidence that they're there, said NIST chemist Christopher Zangmeister. Let's read that quote again. There are a lot of plastic particles wherever we look, trillions per liter. We don't know if those have bad health effects on people or animals. I'm just going to assume it's bad. There are many different types of plastic materials, but they are all made up of polymers, natural or human-made substances composed of large molecules linked together. Scientists have found microscopic particles from these larger plastics in the ocean and many other environments. Researchers categorize them into two groups, micro and nanoplastics. Microplastics are generally considered smaller than 5 millimeters in length and could be seen by the naked eye, while nanoplastics are smaller than 1/millionth of a meter, 1 micrometer, and most can't even be seen with a standard microscope. Recent studies have shown some consumer products that hold liquids or interact with them, such as polypropylene PP, baby balls, and nylon plastic tea bags, release these plastic particles into the surrounding water. In their study, the NIST researchers looked at two types of commercial plastic products: food-grade nylon bags, such as bacon liners, clear plastic sheets placed in baking pans to create a non-stick surface that prevents moisture loss, and single-use hot beverage cups, such as coffee cups. The beverage cups they analyzed were coated with low-density polyethylene, LDPE, a soft, flexible plastic film often used as a liner. The LDPE-lined beverage cups were exposed to water at 100 degrees Celsius, 212 degrees Fahrenheit, for 20 minutes. Let's read that again. LDPE-lined beverage cups were exposed to water at 100 degrees Celsius, 212 degrees Fahrenheit, for 20 minutes. To analyze the nanoparticles released from these plastic products, the researchers first needed to determine how to detect them. Imagine having a cup of water in a generic to-go coffee cup. It could have billions of particles, and we would need to figure out how to find these nanoplastics. It's like finding a needle in a haystack, Zangmeister said. Just want to know, I'm getting bored of reading this article. There's no stress in the world. So he and his colleagues had to use a new approach. We used a way of taking the water that's in the cup, spraying it out into a fine mist, and drying the mist and all that's left within the solution, said Zangmeister. Through this process, the nanoparticles are isolated from the rest of the solution. The technique itself has previously been used to detect tiny particles in the atmosphere, so we're not reinventing the wheel, but applying to a new area, said Zangmeister. After the mist was dried, the nanoparticles in it were sorted by their size and charge. What's charge? Researchers could then specify a particular size, for example, nanoparticles around 100 nanometers, and pass them into a particle counter. The nanoparticles were exposed to hot vapor butanol, a type of alcohol, then cooled down rapidly. As alcohol condensed, the particles swelled from the size of nanometers to micrometers, making them much more detectable. This process is automated and runs by a computer program which counts the particles. High-resolution images of the nanoparticles found in single-use beverage cups, such as coffee cups, at the micrometer, 1/millionth of a meter scale. Researchers could also identify the chemical composition of nanoparticles by placing them on the surface and observing them with techniques known as scanning electron microscopy, which take high-resolution images of a sample using a beam of high-energy electrons, and Fourier transform infrared spectroscopy, a technique that captures the infrared light spectrum of gas, solid, or liquid. All these techniques used together provide a fuller picture of the size and composition of nanoparticles. Like, where are the news articles for just regular people like me? Like, just tell me what to start doing so I can make the biggest changes I have to right now. Jesus Christ. People don't have a lot of time. In their analysis and observations, the researchers found that the average size of the nanoparticles was between 30 nanometers and 80 I'm just gonna skim this shit, not read it out loud, dude. I got Last decade, scientists have found plastics at snow island in Antarctica, the bottom of glacier lakes. People have looked at snow in Antarctica, the bottom of glacial lakes, and found microplastics bigger than about 100 nanometers, meaning they were likely not small enough to enter a cell and cause physical problems. Our study is different because these nanoparticles are really small and a big deal because they could get inside of a cell, possibly disrupting its function, said Zangmeister, who also stressed that no one has determined that would be the case. The FDA's researchers run rigorous tests on these plastics and measure how much plastic mass is lost when exposed to hot water. For example, the FDA has determined that food-grade nylon, such as that used in tea bags, can safely lose up to 1% of its mass under high-temperature conditions. What do you mean safely lose? In the NIST study using their new technique, the researchers found 0.1% of the mass was lost, which is significantly below current FDA limits for what's considered safe. Should we not eat any plastics at all? Consume any plastics at all? Should keep as much plastics from going inside our body, right? Zangmeister noted that there isn't a commonly used test for measuring LDPE that is released into water from samples like coffee cups, but there are tests for nylon plastics. Okay. Let's go back. So, I read a bunch of the comments in this Reddit thread that posted this link, and this one is the one that, I picked one so I could look at it, talk about. All canned goods are lined with plastic, and many are heated or cooked inside the can when packaged. They may say BPA free, but that doesn't mean they don't just switch to a slightly different bisphenol with the same or worse effects. So for lack of a better word, I used to watch lots of Housemaid, and seeing how many things had heat sealed or cooked right in the package made me feel like my move it into a bowl and cover with a plate microwave routine was futile. I'll still do it though. I thought they were lined with tin. It's been plastic for many decades. Always more bullshit to deal with. Go back to see full discussion. Yeah, reading the rest of these comments, what's gonna happen,